Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all of you, especially Madam Juliani, my lecturer for this course, Advanced Differential Equation. My name is Nur Syahira Nabila binti Slamat, and I'm from class EM2414B2. So today I would like to present about the application of Fourier series. So for my presentation today, I'm going to explain what is Fourier series, what is the application of the Fourier series, and also how the application is used the Fourier series step in calculation. First, I'll share some introduction of Fourier series. Next is the application, background study, case study, which I will include some problems with solution, discussion of this case study, and also the conclusion. Let's begin with the introduction. The Fourier series is named after Joseph Fourier, who is a French scientist and mathematician. The Fourier series is an infinite series represent of periodic function in terms of trigonometric sine and cosine function in mathematics. It is an extremely strong approach for solving ordinary differential equation (ODE) and partial differential equation (PDE), especially when periodic functions occur as non-homogeneous terms. Fourier series are conceivable not just for continuous function but also for periodic function, discontinuous function in their value, and derivative of discontinuous. Furthermore, due to the periodic character of Fourier series, a Fourier series produced for one period is valid for all values. Fourier series is used in the analysis of periodic function. This figure shows a periodic function that can be analyzed into their constituents by a process called Fourier analysis. A periodic function is a function that repeats its value in certain period. The period of the function is the interval between two successive repetitions. It is normally defined by specific values over a single period and the length of its period. This figure shows the general Fourier series of a periodic function in the interval -L to L. The application of Fourier series is signal processing. In signal processing, the Fourier transform often takes a time series or a function of continuous time and map it into a frequency spectrum. It takes a function from a time domain into a frequency domain, which it is a decomposition of a function into sinusoid of different frequency. So, signal processing entails converting or changing data in order to precise things in it that are not visible through direct observation. Engineers and scientists can use signal processing to analyze, optimize, and correct signals such as scientific data, audio, stream, image, and video. So this graph displaying the vibration data. Signals in scientific application are frequently corrupted with random noise. Masking their frequency component, the Fourier transform can extract frequencies from random noise. Traditional signal processing is concerned with one-dimension discrete transform. So let's move on to the problems and with the solution. Here are the example. Question 1. The analog signal is band limited to 40 Hz. Suppose the signal is sample at the rate of 100 samples per second, and that at this rate 200 samples are collected. Then 200 zeros are appended to the 200 samples to form a 400-point vector. Then the 4-point DFT of this vector is computed to get xk for k less than 399 and k is greater than 0. So the question asks which DFT coefficient are free of aliasing. The answer is all of the DFT coefficients are free of aliasing. The sampling rate is more than twice the maximum signal frequency. The DFT coefficient x 50 represents the spectrum of the analog signal at what frequency? The answer, the DFT bandwidth is 0.25 Hz. The 50th DFT coefficient corresponds to the frequency of 12 and 5 Hz. Here another example of the problems. with the solution. Here, for this problem, we got some calculation to solve the question by using the Fourier series. Okay, next. This is the graph for the problems before this. Another solution. And from this case study, I'm able to determine the application of Fourier series, which is the signal processing. The Fourier series is specialized tool that allows any periodic signal to decompose into an infinite sum of everlasting sinusoid. In practice, this allowed the Fourier series user to understand a periodic signal as a sum of various frequency components. Various signal properties translate into specific properties of the Fourier series. Signal processing relies heavily on Fourier transform. The most basic, hand-wavy answer is that it is an extremely powerful mathematical tool that allows you to view your signal in a different domain within which several difficult problems become very simple to analyze. It prevalent in nearly every field of engineering and physical science for various reasons, making it very more difficult to pinpoint a cause. So last, in conclusion, case study is carried out successfully. The application of Fourier series is determined. The Fourier series has many applications, and I just explained one of it, which is signal processing. Many of the phenomena studied in engineering and science are periodic in nature, like the current and voltage in an alternating current circuit. In signal processing, the Fourier transform often takes a time series or a function of continuous time and maps it into a frequency spectrum. Fourier transforms are not limited to function of time and temporal frequencies. They can equally be applied to analyze spatial frequency and indeed for nearly any function domain. This justifies their use in such diverse branches as image processing, heat conduction, and automatic control. Okay, that's all from me. I hope you all understand and have a nice day. Thank you very much.